Look up, everyone. Tonight, and tonight only, something truly spectacular is happening right above our heads. The universe is putting on a light show, and you have a front row seat. I'm talking about the Aurora Borealis, the Northern Lights. Usually you'd have to travel way up north to places like Alaska or Norway to catch a glimpse of this celestial ballet. But tonight, the cosmos has decided to bring the magic to us. From Maine to Montana, and maybe even as far south as Colorado or Nebraska, the night sky is alive with shimmering curtains of light. It's a rare and wonderful event, a reminder that our planet is part of a much bigger, much more dynamic cosmic neighborhood. So grab a blanket, find a dark spot, and prepare to be amazed by this incredible natural phenomenon. This isn't science fiction, this is real, observable science happening on a grand scale. So what exactly are the Northern Lights? Let's break it down. At their heart, the Northern Lights are just light, but it's not light from a light bulb or a flashlight. This is light created when tiny particles from the sun crash into the gases in our planet's upper atmosphere. Think of it like a cosmic-scale neon sign. In a neon sign, electricity excites the gas inside the tube, causing it to glow. The Northern Lights work on a similar principle, but instead of a glass tube, we have Earth's entire atmosphere, and instead of electricity from a plug, we have super-energetic particles blasted from the sun. It's a natural light show powered by solar energy, a beautiful and direct result of our planet's relationship with its star. For centuries, people have looked up at these dancing lights with awe, and created stories to explain them. Some ancient cultures believed they were the spirits of their ancestors dancing in the sky. Let's dive deeper into the engine behind this amazing light show, our sun. The sun is a star and it's incredibly active. Its surface is a turbulent place with giant magnetic storms which we can see as sunspots. Sometimes the magnetic field lines on the sun get twisted up and snap, releasing a tremendous amount of energy in what's called a solar flare. Often accompanying these flares is something even bigger, a coronal mass ejection or CME. You can think of a CME as a giant superpowered burp from the sun. It blasts a billion tons of plasma, a cloud of super-hot gas made of charged particles, out into space at millions of miles per hour. It's this solar wind on steroids that's heading our way. But don't worry, we have a planetary superhero protecting us, our magnetic field. Earth has a molten iron core that spins, generating a powerful, invisible magnetic field that surrounds our planet like a protective bubble. When the CME arrives, our magnetosphere deflects most of the harmful particles, but some get trapped and are funneled down the magnetic field lines toward the north and south poles. It's like a cosmic water slide. Normally this entire process happens in a ring around our planet's magnetic poles, which is why the aurora is usually only seen in very high latitude regions. We call this the auroral oval. People in places like Fairbanks, Alaska, or Tromsø, Norway, see the lights pretty regularly because they live right under this oval. For the rest of us living farther south, the aurora is a rare treat. You could stare at the northern sky every single night for years from a place like Chicago or Salt Lake City and never see a thing. That's what makes tonight so incredibly special and noteworthy. So why are we seeing them so far south tonight? It all goes back to that super-powered solar burp, that powerful coronal mass ejection. A really strong CME can hit Earth's magnetosphere with such force that it compresses it and dramatically energizes it. It injects so much energy into our magnetic field that the auroral oval expands, bringing the light show to latitudes that are usually left in the dark. From Maine to Montana and maybe even Colorado or Nebraska. Events like this are tied to the sun's 11-year cycle. Right now, in 2025, we are approaching the solar maximum, the peak when solar flares and powerful CMEs are much more common and intense. So, you want to see the show? The most important thing you can do is get away from city lights. Light pollution from our cities, towns, and even our own houses can easily wash out the aurora's delicate glow. Your best bet is to drive out to a rural area, a state park, or any place with a clear, dark view of the northern horizon. The darker the sky, the more vibrant the colors will appear. Give your eyes at least 15 to 20 minutes to fully adjust to the darkness. When you first step outside, you might not see anything, but as your eyes adapt, the faint glow on the horizon will slowly reveal itself as a shimmering curtain of light. When you find your dark spot, look to the north. At lower latitudes, the aurora will often start as a faint whitish or greenish arc low on the horizon. It might even look like a distant cloud at first, but watch it closely. Unlike a cloud, the aurora will slowly change its shape, brightness, and structure. You might see faint vertical lines begin to appear like searchlights pointing up into the sky, These are called auroral rays. As the storm intensifies, that simple arc can erupt into a breathtaking display of movement and color. People often describe a feeling of profound quiet and awe as they watch. The feeling of seeing the aurora for the first time is something you never forget. Let's talk about the colors. The beautiful colors of the aurora are not random. They are a direct result of atmospheric chemistry. The most common color you'll see is a beautiful, brilliant green. This green light is produced when charged particles collide with oxygen atoms at altitudes between 60 and 150 miles. Our eyes are very sensitive to this shade of green, which is why it's often the brightest and most easily visible color. If the solar storm is particularly strong, you might see other colors as well. A beautiful, rare, all-red aurora can sometimes appear. This happens when particles strike oxygen atoms at very high altitudes, emitting a ruby-red light instead of green. You might also see hints of pink or dark red along the lower edge of an auroral curtain from nitrogen molecules. And sometimes, if you are really lucky, you might see shades of blue and purple, often fainter and harder to see with the naked eye. The patterns are just as spectacular as the colors. The aurora isn't just a static glow, it moves and changes. You might see a simple arc, but then it might erupt into dancing curtains that ripple as if blowing in an invisible wind. Each shape and color tells a scientific story about what's happening in our upper atmosphere. It's a visual data stream from the edge of space. What looks like pure magic is also a beautiful display of physics in action. As the night draws to a close and the first hints of dawn begin to lighten the eastern sky, the celestial light show will slowly fade. The curtains of green and pink will recede, leaving behind the familiar canvas of stars. But the feeling of wonder will remain. Tonight, we were given a powerful reminder that we live on a dynamic, active planet in a dynamic, active solar system. We are not isolated, we are intrinsically connected to the sun and the invisible forces that fill the space around us. The aurora is a visible manifestation of that connection, a bridge between our world and the cosmos. The science behind the aurora makes the experience even more profound. It's a story of immense scale and power. From the nuclear furnace of the sun, to the delicate dance of atoms miles above our heads. Events like tonight's aurora inspire us and spark curiosity in people of all ages. A child who sees the northern lights for the first time might be inspired to become an astronomer, a physicist, or an engineer. These moments of shared wonder can ignite a lifelong passion for learning and discovery. So, as you go about your day tomorrow, carry the memory of this night with you. Remember that you stood on the surface of a planet protected by an invisible magnetic shield, and witnessed a light show powered by a star. The universe is full of such wonders, from the rings of Saturn to distant swirling galaxies. Keep looking up, stay curious. The universe is out there, waiting to be explored, and its greatest shows are often right above our heads, free for everyone to see. Consider it.